There are times that using the trial and error method when factoring can get pretty cumbersome. So there's also another method called the AC method that I'd like to talk about. And this is a method that can be used to solve and to factor any of these quadratics. Given 12x squared plus 17x plus 6, the AC method talks about taking a look at the A, which in this case is 12, and the C, which in this case is 6. And the AC method says to multiply those two together. So AC is equal to 72. To use the AC method now, you need to go through and think, what are all the factors of 72? So I'm going to create a list here. 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9 are all equal to 72. In order to do the AC method, in addition to now going through and writing down all the factors, I'm also now going to go through and I'm going to add all of these together. If I add all of these together, 1 plus 72 gives me 73. 2 plus 36 gives me 38. 3 plus 24 gives me 27. 4 plus 18 gives me 22. 6 plus 12 gives me 18. 8 plus 9 gives me 17. Notice that when I went through and did that, I added those together, I got 17, which is also the middle term, or the B term, in my quadratic equation. So I have that 17. If the middle term number comes up when I go through and add those, that means that this is factorable. And now what I'm going to do is I'm going to rewrite that. Instead of 12x squared plus 17x plus 6, I am going to rewrite it with these for the middle term. So I'm going to rewrite this as 12x squared plus 8x plus 9x plus 6. Notice it's exactly the same quadratic equation. But now I can use the idea of grouping in order to go through and solve this. For the first two terms, I can factor out a 4x. So I'm going to factor out a 4x. I'm going to be left with 3x plus 2. For the second two terms, or for the second set of terms, I should say, the third and the fourth term, I have 9x plus 6. I can factor out a 3. So I'm going to factor out a 3. And I'm going to end up with 3x plus 2. Notice now that I have common factors in both of those terms of 3x plus 2. So I'm going to take out my 3x plus 2 out of both of those terms. I'm going to be left with 4x plus 3. So 12x squared plus 17x plus 6 does factor down to that 3x plus 2 times 4x plus 3. You could go through and check that by using the FOIL method, and you would see that that works. Let's go through and do another one. 4x squared plus 5x plus 6. Using the AC method, A times C is equal to 24, because 4 times 6 gives me 24. So the factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Now I need to check and see whether or not this is actually factorable. So I'm going to add each of these together. 1 plus 24 gives me 25. 2 plus 12 gives me 14. 3 plus 8 gives me 11. 4 plus 6 gives me 10. Notice that the middle term here has a coefficient of 5. And 5 is not in any of these lists. It's not in any of those times where I added. So that tells me that this particular equation is not factorable, and I would just need to leave it the way it is, 4x squared plus 5x plus 6. Here's one more example. 15x squared subtract x subtract 6. For my AC is equal to 90 because 15 times 6 is 90. But it's actually equal to a negative 90 because it's 15 times a negative 6. So when I go through and I write down the factors of this, one of them needs to be positive, one of them needs to be negative. So I'm going to have 1 times negative 90. I can write it that way. I'm going to have 2 times negative 45, 3 times negative 30, 5 times negative 18, 6 times negative 15, and 9 times negative 10. So let me go through and add these together. If I add these together, I have 1 plus negative 90, which gives me a negative 89. Now, one thing I do need to say here, remember, I could have, if I wanted to, I could have had this be a negative 1 and that be a positive 90, because that's still going to give me a negative 90. If I did that, that would have given me a positive 89. This actually could be a positive or a negative 89. I'm going to end up wanting to see if it's a negative out here, which is why I'm doing the negatives all the time, but either one of those would go through and work. So if I have the 2 plus a negative 45, that gives me a negative 43. 3 plus a negative 30 gives me a negative 27. 5 plus a negative 18 gives me a negative 13. 6 plus a negative 15 gives me a negative 9. And 9 plus a negative 10 gives me a negative 1. I did get that middle term. I got a negative 1 because there's an understood 1 in front of there. So now what I'm going to do is I'm going to rewrite this using the 9 and the negative 10 in place of that minus x. So when I rewrite this, now I have 15x squared plus 9x minus 10x minus 6. That plus 9x minus 10x is the same thing as a minus 1x, which is what I had. Now I'm going to go through and I am going to factor this by grouping. I have 15x squared plus 9x. I can factor out a 3x out of those, and I'm going to be left with 5x plus 3. For the 10x minus 6, I can factor out a 2 out of those. If I factor out a 2, once again, I'm left with a 5x, and I'm going to be left with a 5x plus 3, because remember, this is a subtraction out here, and the subtraction sign applies to everything. So if I were to go through and use the distributive property for this section, I would get subtract 10x, subtract 6, which is what I have. So now I have a common 5x plus 3 in both of those terms. So I'm going to factor out the 5x plus 3 in the first term, leaving me with a 3x. I'm going to factor out the 5x plus 3 in the second term, leaving me with a 3x subtract 2. So the final answer to this is 5x plus 3 times 3x minus 2. Many people find the AC method of factoring to be helpful, especially when having more difficult problems. You can choose to use either the guess and check method or the AC method as you are doing these problems.